This video is about reference angles. So a reference angle is an angle that is drawn from the terminal side of an angle to the x-axis. So if I have an example, for example, if I have a angle like this is my angle theta. The reference angle is the angle that's created when I finish off that angle down to the x-axis. A reference angle is always drawn to the x-axis. And we're going to label the reference angle alpha. And we even get this little reference triangle. So if we know the measure of theta, we can find the measure of the reference angle alpha. And depending on the location of our terminal side, which is this side right here, depending on the location of that terminal side of our angle theta, we're going to have to find alpha in different ways. The key things we need to know, if we're working in degrees, halfway around is 180 degrees, and going all the way around is 360 degrees. And if we're working in radians, halfway around is pi, and all the way around is 2 pi. Pi is also the same thing as 3.14, and 2 pi is the same thing as 6.28. So sometimes if we're working with decimals, we'll use the decimal versions of the radian values. So let's do some examples. So we begin with an angle of 4.2 radians. First of all, we need to sketch that angle, so we need to know approximately where 4.2 radians is. But we know that halfway around is 3.14, or pi, and all the way around is 6.28. So since we start at the positive x-axis, and it's a positive angle, we're going to move around counterclockwise. We're going to go more than 3 because it's 4.2. So I'm going to approximate that angle is somewhere over in the third quadrant. And I'm going to label that angle theta. Now my reference angle, which I'm going to call alpha, will be drawn to the x-axis. So this here is alpha. And alpha is going to be found by taking my 4.2 radians and subtracting off the 3.14 radians, that is just from 0 to halfway around. So I don't need all of that because alpha is just this part that's in the third quadrant. So when I subtract 4.2 minus 3.14, I get 1.06. So the measure of alpha is 1.06 radians. Now we won't always be subtracting. If alpha had ended up in the second quadrant, I'd end up doing 3.14 minus theta in order to find alpha. And if alpha had been in the fourth quadrant and theta had been like that, I would have had to subtract from 360 to get alpha. So you have to look at the picture to figure out what to do. Ooh, scratch that. I said 360, but I meant to say 2 pi or 6.28 because I'm working in radians. But that's a good transition. Let's go to degrees now. So if I'm working in degrees, it's the same general process. You'll notice this time our angle is negative. That means I'm going to start at the positive x-axis, but I'm going to move clockwise around until I get 300. I'm going to move clockwise around until I've gone 314 degrees. So there's my angle. That's theta. And I need to draw my reference angle. Now my reference angle is always drawn to the x-axis, so this is alpha right here. And to find the value of alpha, I know theta is 314, but it's negative. So to find the value of alpha, I need to figure out what's left in the whole circle. Now in degrees, we have 360 here, and we have 180 over here. So to find alpha in this case, I have to do 360 subtract 314. And when I do that, I get 46. So that's going to be my value of alpha in this example. So remember, your reference triangle is always drawn to the x-axis, and to find it, depending on if you're working in degrees or radians, you will subtract or add to 180, 360, 3.14, or 6.28, depending on where your angle is located.